Well, hello, Algebra 1. Welcome to the 1-6 lesson videos on compound inequalities. So we just finished inequalities in section 1.5, so now we're going to throw this word compound on there. And compound simply just means two or more, right? Usually it just means two compound inequalities. And you'll see in these examples of how we're going to do this. 1 second. Cool. All right. So it says, example 1, understand compound inequalities. It says, how can you use inequalities to describe the set of numbers graphed below? So if you look at this inequality, right? So I see array on the -3, solid dot going to the left, right? Then I see another ray, open circle at the 2 going to the right. So a couple things. First of all, because there are two separate rays, we're going to use this word or in between them. Or. Because no number in the known universe can be on the left ray and the right ray. So it's not and. It's either on the left ray or it's on the right ray. Right ray. The other thing is that these dots, because this -3 has a solid dot, that means that this inequality is going to have an equal to. Because this is an open, this is not going to have an equal to. So it's not going to have the line underneath it. So in this picture, the left ray represents all numbers x that are less than or equal to -3 because they go to the left and they have a solid dot. Then we put that word or in between. And then the right ray represents all numbers x that are greater than, not equal to, just greater than 2. There is your solution. This is the compound inequality that represents this graph. So again, as you can see, the graph above shows the solution of two inequalities. These two inequalities form a compound inequality. And as I said, a compound inequality is just two or more inequalities. There we go. Now, I do notice that I did not use a capital or, I just used a lowercase or. That's probably more appropriate because that's what you'll see. Or, right? But I like to emphasize or. Okay, so that's the word or. Nice. Next. Okay, so it says, how can you use inequalities to describe the set of numbers graphed below? So again, now, notice that you don't have two separate rays going off. You have this like middle section. From geometry, you might call this a segment, right? So because there is just one section in the middle, this is going to be an and, a compound inequality. Notice the -4 is a solid circle, so that's going to be equal to. The 1 is an open circle, so that's not going to be equal to. So if you were to take this and break this up into two separate inequalities graphed, let me draw this number line here. Right, so here's the number line. Let's put -4 right there. Let's put +1 there. So if you were to take the first inequality, right? Let's do what? Let's do the 4, right? If I were to put a solid dot here, 4, this graph would go off to the right. Right? But then if I were to, for the 1, put an open circle and go off to the left, this would be the graph of the two separate inequalities that make up this compound inequality. But notice where they overlap. These two inequalities overlap right here and here. So that is why the compound inequality for these two inequalities is the middle section right there. Because these two, instead of going in opposite directions like the or, these two inequalities go towards each other and overlap in the middle somewhere. So we can write this answer two ways. Number one, we can describe these two inequalities that I have here in gold and blue. So you could write this answer as x is greater than or equal to -4 and x is less than 1. So that would be describing the orange ray first and then the blue ray second. That could be one of your answers. You can also do it using one fluid inequality symbol or one fluid inequality with no and. You would put the -4 on the left, you'd put the x in the middle, you'd put the 1 on the right, just like it looks here. -4, x in the middle, 1 on the right. You would put a less than or equal to for the between the -4 and the x, and you have to almost read it like this: x is greater than or equal to -4. You have to read it backwards, right? But equal to because it's solid. And then you put a less than next to the 1, and you go ahead and read this way: x is less than 1, which is what it is. This would be a compound inequality, and if you want to write like this, you're going to see this a lot more often than the separate with the word and in between. The trick is this one right here. A lot of people don't put the less than, they'll write it like this. They'll do like this: -4 greater than or equal to x, less than, because they want to read it left to right like this one. It's you can't read it left to right like this one because the x is first here, but for this part, the x is second. So it actually has to be flipped around, right? So that's why you must use this one up here, because that flips around. This is not correct. This is correct, flipped around. All right. So hopefully that makes a little bit of sense to you. All right, nice. So let's continue talking about more compound inequalities. So it says, example 2, solve a compound inequality involving or. Solve the compound inequality 5x minus 7 is less than 13, or -4x plus 3 is greater than 11, and graph the solution. So this is pretty simple. All you do is you take these two inequalities and you solve them individually. So let's take the first one. 5x minus 7 is less than 13. What's happening to the x? Being multiplied by 5, being subtracted by 7. So let's add 7 to both sides. 5x is less than 20. And let's divide by 5 on both sides. X is less than 4. Very good. So that's that part. Now I bring down this big giant or in between them. And now let's do the right one. So -4x plus 3 is greater than 11. Two things happening to x: being multiplied by -4, being added to 3. So let's subtract 3. So -4x is greater than 8. And now let's divide by -4. And I hope your red sirens going off in your head, because when you divide by a negative, you must reverse the symbol. Reverse. Like you're playing Uno, reverse, right? So x comes down, the inequality symbol reverses to a less than, and 8 divided by -4 is -2. Okay, and now this is the solution from here. So now we're going to graph this, and right now it might not look strange, but notice that these two symbols are both less than. They go in the same direction. This typically doesn't occur. Typically, one is less than, one's greater than, and they go in opposite directions. But you'll see these are less than and less than, so watch what happens, right? So let's draw a number line. Okay, let's do them. Let's do them like this. So we're going to put the -2 here and the 4 there. So x is less than 4. Open circle going to the left, less than. X is less than -2. Open circle going to the left. So because of the word or, we don't need to be a number on both of these solutions. We can be on one or the other or both. Okay? So for instance, we could be the number 3. 3 is on this one. We could still be -2 because -2 is on this one. It's not on the top one because those, but we could be -5. -5 is on both of them. So the true solution to this inequality is going to be the bigger number line, or the bigger ray. So that'd be the bottom one. So we are going to, because it's or, we are going to keep the bigger solution set. And that is because we can be on either or graph. So in the end, the answer to this inequality is actually just x is less than 4. And the graph is just going to be that one with the 4, x is less than 4. So again, that was kind of a weird example. Very interesting they did this one. I think they just think that ors are not complex, that if you just had a regular or, you'd be able to graph them going separately and be good, like the very first example we did. Okay, so I'm going to stop the video here, and we'll pick up where we left off in the next video.